Hello everyone, I'm happy to see you at our English language workshop dedicated to refactoring techniques. Before we begin, I'd like to remind you of few basic rules. The session will last about an hour and will be conducted entirely in English. And you're welcome to ask any questions during and after the lecture, and our speaker will answer them. So I think that we can start.
I'm going to share my screen. Okay. Hi, everyone. My name is Saeed, and I have 12 years of industry experience. Today, I'm going to talk about code refactoring techniques. Let's first look at the agenda for today. So first, I will start with defining what are the code quality metrics and how can we analyze those metrics. And then we will see why refactoring is important and the list of tools, the most famous ones, which can make the refactoring process easy. Then we will look at the main thing, which is the key refactoring techniques. And I will also share the code and that list of techniques. Then we will look at the best practices. And finally, we will see the common mistakes even the experienced developers make. So let's start with the first item, which is the code quality metrics. So to define code quality, we can use a list of well-defined metrics. These are the most common ones. There can be more. The first and the most important one is the readability of the code. So, and then we have like reliability, reusability, testability, like how much portion of the code is unit testable. Then maintainable, is the code maintainable? Is it like efficient or not, which is related to directly to the performance. And then extensibility, which is more about like how can I add more features to this application or not. So these are the list of metrics. We'll see like how can we make the code better. So these metrics can be improved. But first, we have a metrics list of metrics, but we need to measure them. To measure the code quality, we have like famous tools. The first is the Sonar Cube. This is the most famous one available in the market. It integrates well into the CI/CD. We can create project in the Sonar Cube and it will analyze all the code and it will give a report of the code health. So that health is like if you look at the screenshot on the right, so we have a list of like, for example, if how many bugs are there, how many vulnerabilities, how many code smells are there, the percentage of code which is duplicated, how much code is covered by the unit test. It can have a lot of data and insights that can help us analyze the quality of our code. And if we are going with only JavaScript and TypeScript, then the most famous one is the ESLint. It integrates well into the CI/CD and it can provide a similar report like SonarCube. But the most important thing to note is that these automatic analysis tools, they cannot measure all metrics easily. So if we look at the first metrics, which it is about readability. So when we say readability, we can configure certain rules that like, if the code, like for example, the nesting in the code, the naming in the code, it's like it can have a lot of different ways to analyze like what is the readability of the code. But we cannot basically list down almost everything that can help us decide if the code is readable or not. We can decide really if the code is readable or not when we actually start working with the code base and we start adding features into that. Let's look at why refactoring is important. First is like basically to make the code more readable and maintainable because it directly impacts the developer velocity, the cost of maintenance of the code. If the code is a spaghetti code, it will be expensive to maintain. Adding any feature will create more problem, and it will basically just increase the size of the mess our code has been. And then performance and scalability, we can enhance performance and scalability using refactoring. I will show an example when we later on, like how to convert synchronous code into asynchronous code to improve the performance. And then the technical depth. The technical depth is basically the same thing which I showed in the Sonar Cube example, that it has like code smells, the duplication code, and like all of these things. And then to prevent the future bugs. So if the code is not organized well, adding even a tiniest of the things will start affecting the things. Like for example, it will start breaking things. It will start having unexpected issues because the code is not organized well. Let's look at the list of tools that make the whole refactoring process easier. Um, the most common one and my personal favorite is the GitHub Copilot. It has a really nice like integration with famous tools like Visual Studio. I will show when we go into the Visual Studio. I will show how to use GitHub Copilot to refactor the functions, to refactor the classes. And then also we have the IntelliCode, which is basically created by Microsoft. It comes by default in the Visual Studio. It is not as elegant as GitHub Copilot and ReSharper, but yeah, it's more like a basic refactoring. And then we have a very famous tool in the market called ReSharper. So ReSharper, it's also quite famous, but it is again like it is for basic refactorings, like for example, like renaming, splitting methods, and this kind of stuff. But it is not like, I mean, it doesn't refactor a whole like a whole class, or we cannot say that okay, I'll use basically refactor this code using certain way. So it doesn't provide us full control like GitHub Copilot does, but it is still a quite a decent tool for refactoring. I'll show the demo with the ReSharper as well. For most of the examples that I will share in this training, I will use GitHub Copilot, and just a note that privacy and security concerns are out of the scope for this training. Yeah, I mean, any tools which is built with AI, it has this concerns with privacy, because we are giving access of the code base to the tool, and it might train its AI with that tool. So that is out of the scope for this training. Okay, let's look at the key refactoring techniques. There actually, just to be clear, just to clarify, there are a lot of refactoring techniques. These are the ones which are most common, and I have basically filtered down a list of the refactoring techniques. The first is the composing method technique. So in this technique, are refactoring a portion of a code into a separate function. We can also do a reverse of that. I will go deeper into that as we move to the next slide. But yeah, this is a more like a general list of all the refactoring techniques that we are going to discuss today. The second will be like synchronous to asynchronous refactoring, and then moving features between objects, and then it will be simplifying conditional expressions, which is quite interesting. And the next is the simplifying method calls. Then it will be remove duplication. And finally, I will also share some insights into like how can we make our code better using patterns. I also have like a demo for one pattern, but because the patterns are they are so much details, we cannot go into all of them in this training. Let's start with the first one, which is the composing method. So in the composing method, the very first thing we can do is extracting a method, which is basically like, let's assume that we have a long method. We can extract certain parts of the implementation into their own methods. And then the next one is the inline method, which is we actually do the reverse of the extraction when it is needed. I will share an example. And then extracting a certain implementation into its own variable. So these are the three main techniques for composing method. And yeah, let's go into the demo. Let's start with the first one, extract method. So here we have a function. It's called create buyer. It takes a buyer. Um, the very first thing it does is like it validates all the fields like name, contact, email, and address. If there is any validation error, it will just return the error. Otherwise, it will also validate that this buyer already exists. And if it does not, then finally it will just add the buyer into the list of buyers. This function has problems. It is doing more things than it should, like all of these validations. Like let's say when we start adding more properties into the buyer class, like for example, we add, let's say the work phone number or more fields, then this list will keep on growing. And every person who adds a new validation, he'll just say that, yeah, I'm following the same pattern, I'm following the same logic. So this list will keep on going. Um, this is something that shouldn't happen. We can actually refactor this function to extract the validation logic into its own function. So let's say we create another function. Let's call it public string validate buyer. And it will take a buyer data. Yeah. So this function takes a buyer data and it does exactly the same type of validations that we were doing in the main function. And now here we can remove actually all of this up till here. And we are for any kind of validation, we are just saying validate buyer and we are providing it a buyer. So it will return us a string, which is an error message, and this line will stay the same. So moving the validation logic out of this function, now what is the benefit? The benefit is like this function is clean. It is doing exactly what it should. It is just creating a buyer. It is not doing any kind of validation. It is just calling another function. This function, validate buyer, it is unit testable. Like we can have a unit test which is testing all possible errors. So we have separated the validation logic from this main function. Now this whole all thing was done manually. What if we want to use a tool to refactor this thing? Let's see it works. I'm going to revert this change and let's ask GitHub Copilot to refactor this for us. Let's see if it can do it. So I have this function, this create buyer, and I'm going to ask GitHub Copilot. So this is an extension in Visual Studio, which basically just integrates with my GitHub Copilot account. And here I'm going to ask it like, okay, refactor this function using extract method. Let's see if it understands this technique or not. It might take like a few seconds. So it has done the similar thing which I did. It has created another function called validate buyer, moved everything into that, and it just called the same function, the new validate buyer function, and just it did exactly what I did. So using the GitHub Copilot, we don't need to manually refactor this. But the important thing here is to understand what this technique is, because we can't completely rely on the outcome of this GitHub Copilot, because if it is wrong, we can't, if we don't understand what do we want, then whatever it suggests, we'll simply accept that, which shouldn't be the case. We should know exactly what we want. So we can do this manually as well as with the GitHub Copilot. Next function, let's see this print buyer. So what it does is like it is taking a buyer data and it is printing a header, which is just this title and then and basically just printing this header stuff. And then it is printing the details of the buyer, like name and email address. There is a problem with this function. It is printing a header, but it's also printing the details. let's say there is another place where I don't want to print a header. I just want to print the details of the buyers. Then what we will do? So I'll just create another function. I'll just copy all of this stuff into that function, which shouldn't be the case. This function print buyer, it shouldn't know what are the buyer details and all that. It shouldn't know that I need to print a header and I need to print a buyer. So which means I can simply just say like print like let's say void print buyer. Let's call it buyer details. And here I'm providing a buyer data again, buyer. So all of this buyer details printing part will actually go in this function. And here I can simply call this dot print buyer details. And I need to provide it a buyer. So here, now this function is testable. It is only validating the details of the buyer. It doesn't need to know about header. We have decoupled the header from the buyer details now. I'm going to revert that. Let's see if AI can do that for us, if GitHub Copilot can do that for us. I'm going to select this function, again, ask Copilot. So I'm saying refactor this function using extract method. Because I know exactly where I want to go. So now I can trust GitHub Copilot to do the refactoring for us. And if I see that, yeah, it has done the same thing, I can simply just accept the suggestion. So here it has done the same thing which I did. But print buyer details is a new function. It is doing everything. So yeah, it didn't change anything in the header. It stayed like that. It just split this buyer function into these two separate, and it just decoupled the header from the details. This is the extract method. Now let's go to the inline method, which is basically the opposite of extraction. So here we have a function and it is taking a variable called number of late deliveries. And it is calling another function, which is more than 5 late deliveries. And if there are more than 5 late deliveries, it is returning a rating of 2. Otherwise, it is running 1. The problem with this function is this function, it seems useless because what it is, it is just taking an integer and it is just comparing an integer with another integer. Like, do we really need that? Let's see if GitHub Copilot can refactor this for us. Ideally, what we want is we want to remove this function. We want to just get this implementation inline here. That's why it's called inline method. We don't want another function which will just add another layer of complexity and another layer of like another calls on top of that. So let's see. Here I'm going to ask Copilot to actually refactor this function using inline method. Yeah. So this is exactly what I wanted. I wanted to delete this function. I wanted to bring the implementation into this function. And yeah, so it is here. It has done exactly what I wanted. Let's move on to the next one, which was the extracting variable. So this in this extract variable, let's say we have a function called render content. So it is doing this bunch of checks, which looks quite, I mean, confusing. Like it is checking that the platform uppercasing, and then it contains Mac or not. And then it is doing the same thing for browser, that the browser is IE or not. And then it is initialized and resized greater than 0, like whatever. So all of this, validation, um, it looks quite confusing because, for example, if I want to add one more validation, I'll go ahead and add it here, and then it will keep on growing as well. To make it cleaner, we can use the extract variable method, and we can actually extract this implementation details into their own variables. So they are reusable, they are testable. Right now, if I want to test this function like render content, I have to write a test this render content for all different variants of like, does it contain Mac, does it contain does not Mac versus Mac. So let's ask the GitHub Copilot to actually refactor this for us. So I'm going to ask refactor, refactor this function using extract variable. Uh, let's see if it understands that. Yeah, so it does. So in here, let's see what it does. So it has extracted this all of this logic of checking is it a Mac platform or not into its own variable. So now this thing is testable. Going forward, I can actually just move all of this outside here. So um, this platform is not null here. Yeah, so we can remove that, whatever. So the same for browser is initialized. Yeah, it is basically, we have to call it in another function because it doesn't allow calling it here, like outside in the class. It has to be in a certain function. But for example, like let's say this resize. So now we have these four different variables, like all of the implementation is extracted into these separate variables, and this if check is quite straightforward. The readability has improved a lot. The expectation from this function is not changed. Like what it was supposed to do before, it will still do it, but it is just extracting. It has just split that all of those complex checks into their own variable. So now it is readable. Um, the next technique is synchronous to asynchronous. So this is quite interesting. Um, every language now has asynchronous features like most modern languages do. Why do we need that? This is mainly for performance. So for example, if we have a UI thread and we are making, let's say there is a button click on the UI thread, and now we are going to run a function, and this function is going to take a long processing time. Assume that this calculate sum was called when there was some action happened on the UI and it gets a list of numbers, and it has assumed that it has like 1 million numbers, and some adding all of these 1 million numbers and getting a sum is going to take some time. And if we're going to just let it happen like that, it is going to add delay on the UI, and it is going to basically the user experience will be worse. So what we can do here is we can offload the responsibility from the UI thread into a separate one. And in C sharp, there is a certain syntax. So we can do task.run. And I'm going to run this function as a separate task. Now, if I have a task, inside any function, that function needs to be async. That has to be a task of this. And this we need to also await that. So now what will happen is as soon as this function is called, it is executing a task. And when the task is completed, the caller will actually get the result back. So it is not blocking the main UI thread. If I'm going to just revert that. Here, let's ask Copilot to actually do this for us. So refactor this function to make it async. Let's see if Copilot can do it. Yeah. So the end result is exactly the same like I did. It has created this function. It has also and did another thing. So it has added this async suffix into the name of the function because that is naming convention in C sharp that anything that is async should have a function like an async prefix in the method name. So In the implementation, it's doing the same thing. It is creating a task. It's not blocking a UI thread. It will significantly boost the performance of the application. This is just one example of like a heavy and expensive function. Let's say if we are calling multiple functions. So for example, if I'm calling this long running operation with a different value, then I need to call it again, and then I need to call it again. So altogether, the performance of this sequence of steps is going to add up. So for example, if for example, this long running operation, it is taking 2 seconds, so it will be 2 seconds and then another 2 seconds, so 4, and then another 2 seconds, which is 6. So it's going to take 6 seconds. But if we make it asynchronous, we can actually make it 2 instead of 6. And that will be exactly what I did in the previous example. Like we can run this long running operation as a task, and we can wait all of the tasks to complete, and they will be running in parallel. I'm going to ask Copilot to do that for me. And the end result which I'm expecting is basically it will have an array of tasks, and it is going to await all the tasks at once. So let's see if it can do that for me. I'm going to select this and I'm going to say, okay, Copilot. So refactor this to make it async. Let's see. Okay, I'm going to accept the suggestion because it will be readable then. Yeah. So what it has done is it has created a list of tasks here. And all of this here at this point, we are waiting for all the tasks to complete. And in here, it is just like this is just an example. Like it is basically waiting for 2 seconds before it considered the task to be completed. So in here we are waiting for all the tasks. All of those tasks are running in parallel, running it asynchronously, and we have given the control back to the main thread when this thing will complete, which is because we are running it in as a tasks in parallel. So it will altogether take 2 seconds instead of 6 seconds. So that way, to improve the application performance, we can convert the synchronous code into an asynchronous code. There is one catch here. The catch is like, as soon as we make this function async, anyone who is calling this function also needs to be async. So it will have like a kind of a ripple effect going all over the application. But yeah, that's just like an idea of like how can we convert the synchronous code into the asynchronous code to improve its performance. Next thing is moving features between objects. So here we have two basic techniques of moving method, and the next is moving class. Let's see what I'm talking about. So moving feature, the first has, let's say, moving method. So we have a class called shape, and the shape has a function called log drawing, which is basically taking a logger, and it is making a message that should be logged, and then it is calling the logger.log. And then we have another class called logger, and it is like just logging the given message. The problem with this is like any kind of logging functionality should be in the same place. So this log drawing, it shouldn't belong to the shape because it is a logging specific logic, and all the logging specific logic, it should be moved in one place. Like it should be all the logging specific logic should be inside this logger. I'm going to ask Copilot to do that for me. Let's see if it understands or not. So refactor this code using move method. What I'm expecting is it will move this function in here, and it will adjust like how that function is being called. And let's see. So I'm going to accept. Let's see what is the output. So here, yeah. So here it has moved the logger function in here. Now it is just taking an object, preparing a message that should be logged, and just logging that message. In the shape class, we have the draw function, and now it is just calling the logger.log drawing. So let's say we have another similar class which wants to log, like all the logging specific functionality should be in the logger, and this function actually just need to offload that responsibility onto the logger. So just provide the object. Now it is the logger's responsibility to do whatever it wants to do with that. The next is the move class. So we have a user, and the user has name, email, area code, and number. And there is a function called get telephone number. If you look at this functionality, what it is doing is like it is concatenating a telephone number by using this parentheses and then area code and then number. All of this functionality, first of all, it should be reusable. Like maybe we have a user class, but then there is another class. So that functionality, it should be in a place that is not coupled together with the user. um, and these properties, anytime, let's say we want to add like another property related to the telephone number, it means I need to update this user class. And if these same properties were copied into another class, it means I need to update that class as well. So all of this information, this is what is this for? This is only for the telephone number. So it means I can extract all of this logic into a separate class. Let's actually ask Copilot to do that. So I'm expecting that it will extract area code, number, and this get telephone number into a separate class. And it will just put a new property in here, which is just a telephone number. User doesn't need to know about internal implementation of the telephone number, like how this string is formed, what exactly do we need for telephone number. User just need to know that, yeah, this is the telephone number, and that's it. Let's try to extract this. So here I'm going to ask it to refactor this using move class. So here it has created a new class called telephone number. Let me just move it here. I don't know if I can move. Yeah. Um, it's not resizable. Okay, it is. Yeah. So here what it has does is it has created a new class called telephone number, move all the telephone number specific properties and functions into the telephone number class. So now this class is coherent and not coupled with the telephone internal implementation of the telephone number. It just need to know what the telephone number is, and that's it. So that way, like using the move class refactor, we can like decouple the implementation details out of this main user class. Let's go to the next one, which is this one is quite interesting. So simplifying conditional expressions. The first one is the consolidate conditional expression. So simplifying conditional consolidate here. Yeah. So let's say we have a function called disability amount. It is taking age, month disabled, and is part-time. Now it is doing a bunch of stuff. Like it is checking if the age is less than 2, no benefit, no disability amount. If the months is greater than 12 and it is a part-time, then no. Otherwise, it just returns, it has its own implementation, which we don't care about. We, if we look at all of these things, all of these validations, they shouldn't belong in this class because they need to be in a separate function. They need to be testable. They should be independent of how much amount are we going to calculate, but because these are just the validation. So ideally, we should extract this and we should create a function let's call it public, let's call it Boolean, and is, let's say, not eligible for this ability. And all of this stuff, it will go here. Um, and instead of this 0, and I'm going to do it like, yes, this is true, which means it is not eligible. And same here, same here, and I'm going to return false. False means yes, the user is eligible. Now it needs these 3 things to decide here. And here we can just call the same function if is not eligible, and I can provide the age, then we are going to return 0. So here we have simplified these conditional expressions and move them into a separate function. So the complexity of this disability amount function, it is reduced now. The next thing is the replace conditional with polymorphism, and this is quite an entry pattern which at least I have seen in many of the code bases. So assume that we have a bird class and it has a bird type, and based on that type, we are taking some decisions. Like for example, if we want to calculate the speed, it can be anything, not only speed, but yeah, this is just an example. So the idea is like based on the type of the bird, we are taking some decisions here. Like it can be different values, it can be different computations, different formula or whatever. This is we are doing for like one function. Let's say if we want to do it, like let's say if we have the similar set of statements in another function, like let's say if we want to calculate, okay, give me the, let's say, color of the bird or whatever. So we need to repeat all of these conditionals in that function as well. We shouldn't be doing that. We should be replacing this conditional using proper polymorphism. And that would be, we can actually create subtypes of the bird. Like we have this bird enumeration here, but we can create different classes for that bird, and each subclass of the bird will actually override the value. For example, the get speed. So each subclass of that bird, the main supertype bird, will actually override the function called get speed. It will provide their own speed. Like for example, for African, for example, let's say it is 10, for American it is 20. So let's say if, just to save time, let's say if Copilot can do that for us. So it is easier to understand what I'm talking about. So refactor this using replace conditional with polymorphism. I'm not sure if it can do that, but let's see if it can make our life easier. Okay, nice. It can do that for us. I'll just accept it for now, just to make it easier to see what's going on. It has created some of the mess as well, but yeah, the main idea starts from here. So it has made this bird class an abstract class. It has created a subtype called African bird, which extends from this bird, and it overrides this function, the get speed. And same for the American bird, the European bird, like all these types. Now, there is no conditional, and this was just get speed. Let's assume that we had another function called get maybe weight. So all of these classes will actually provide the implementation for that. And if we didn't do that, if I'm going to revert it, yeah, then in the like in the new function, we actually needed to have another switch statement and then do the same thing. Like if it is African, do that. If it is American, do that, which was just like a redundant thing. So using this replacing conditional with polymorphism, we can actually avoid this complexity of using conditionals and using switches and all that. The next is replacing conditional with guard clauses. So this is, if you look at this function, get amount, this is a lot of nesting. Like if it is there, then do that. And otherwise we are, if it is separated, we have a lot of nesting. Like Ideally, the goal should be to reduce the levels of nesting that we have. Here it is like 1, 2, and 3. Like it is a lot of nesting. We shouldn't be doing that. Is there any way that we can actually refactor this code to reduce this nesting? I think there is, because eventually what we are doing here is we are, for example, if it is dead, we are just getting that amount, the dead amount, and just we are returning from here. So why don't we just return it from the top instead of going all the way and preventing all of those if else checks and adding all of those nesting? Um, to refactor that, I'm first going to ask Copilot. Let's see if it can do that. So refactor this using replace nested conditional with guard clauses. So my expectation is that it will add the guard clauses on top. Like if it is that, just redundant it from there. It doesn't need to like come all the way and do all of this kind of nesting. It should be just like one level of nesting and that's it. So I'm going to accept that. So yeah, it has done it for us very nicely. If it is that, we are just returning the red amount. No more nesting. Same for separated, same for retired. Otherwise, fall back to this normal pay amount. So if we just look at the complexity of this function versus what it was before, I think this function is a lot less complex now. It doesn't has any kind of fancy like a nesting implementing and like it is just much more easier to read. Yeah, let's go to the next one. Simplifying method calls. This is quite basic. Let's go. It has two things. So the first is to introduce a parameter object. Let's say we have a function like which basically take date, like start date and end date, and it calculate the amount of the invoice. And then there is another function which does the same thing. Now, if we have, let's say, another function, um, let's say XYZ, and it is taking the same thing. So here I'm adding more and more like this the thing which is like I'm adding start date and end date to all of the related functions. But let's say tomorrow we decide that okay, we need to add we have a start date and end date. Let's say we need to add just an example like time zone. So what we need to do is like we need to take the we need to do we need to take the time zone and we need to put the time zone everywhere where this is required. This is a bad design. We shouldn't be doing that. So what we can do is we can extract this list of parameters and we can make it an object. Like we can have, for example, a date range that will have the start date and end date and any other properties which are basically required by all of these functions. So I'm going to save time. I'm going to ask Copilot to do that. So refactor using parameter object. My expectation is it will create a new class called date range or something, and then it will move the same properties that it has into that, and then this function amount received and okay, yeah, it has that. So here now all of these functions are taking a date range, and tomorrow if we want to add a new property time zone, I'll just go ahead and here I will just add my time zone. I don't need to update all of these classes. Oh, sorry, all of these functions and all the references. I don't need to do anything. I'm just going to update this date range. And I think this is quite a famous thing. Like any function that starts with like, for example, now we have 2 parameters. Tomorrow there will be 3, and it keeps on growing like 5, 6, 7. So if we are having a class for a parameter, like for a parameter object, it will make our life easier and it will make our code cleaner. The next is the rename method under the like simplifying method calls. So in this rename method, like I think it's quite common that sometimes we use shortcuts. Like for example, this one is like circum. Now, what is circum? I don't know. until I read the implementation detail. Oh, it is calculating the circumference of a circle. So that's why like someone tried to be clever and use the short form circum. Here, I'm not going to use Copilot. I'm going to use ReSharper. For this small and basic stuff, ReSharper is enough for us. So here I'm going to like see, first of all, let's say I'm going to use this bulb sign, which is provided by ReSharper, and I'm going to see like what are the suggestions. So ReSharper is telling me that there is a typo in circum, and circum is like not really a word. What it does, now it will ask us like, what do you want to rename? And if I use ReSharper to rename this function, it will update all the references of this function as well. So I don't have to like manually go in like and update like hundreds of references. It will just update in the whole code base, like all the references. Um, this is for ReSharper. Let's see if I'm going to ask Copilot. So I will say refactor this function using maybe better name, or let's call it like a rename method. I'm not sure if it can guess the right name which I want, but let's see. Maybe it understands the implementation. Oh, yeah, it does. So it has gone into the implementation. It has read the command and it has created a proper name for my function. For renaming, I think using Copilot is too much. We should be ReSharper or manual refactoring or manual like renaming. It should be more than enough. And another example is the get customer name. So this function is quite similar to the previous one, where someone tried to use a shortcut like get custom name, which in fact actually returns the customer name. So here we can just I mean, let's see if ReSharper can detect. So remove onion method. No, ReSharper is not complaining because this is a whole word. Um, Ideally, this function should be the full name. So get customer name, and that's it. Now it represents exactly what it is doing. The caller, the reader of the function, they don't have to like think twice, oh, what this function is doing or not. So the idea is to use the better naming used like it doesn't mean like use a function name which is like taking a full line or like maybe 50-60 characters, but at least where we have the capacity. For instance, in this case, get cust name versus get customer name, it doesn't make any difference at all, but it make a difference in terms of readability. So here we should be using the full name of the function, and then yeah, the same for the circum. So we should be using the circumference instead of the circum. The next is the pattern. So we have like a list of design patterns that are quite industry standard, and they are basically solutions to commonly occurring problems in the design. They are in three categories: creational, behavior, and structural. The most important, the most common one I have seen is the factory pattern. I can give some demo. I think we still have like some time, so I can give it a quick demo on that. But yeah, we have other design patterns as well, which I will not include in today training, but I would suggest everyone to like, I mean, understand like what these patterns are, and to make the code base more maintainable, try to refactor the code using these design patterns. Like, for example, if you're going to build an object, then try to use a builder pattern. We are going to create something, try to use a factory pattern to hide the creation logic. Let me just quickly show the, uh, the, the factory pattern here. So here we have a credit card interface, and then we have a gold subclass, and then we have a titanium class, and then platinum class. So all of these classes implement this credit card interface. Um, the main problem is here. So when we are going to create those objects, let's say I know a card type which I'm going to create. I need to know exactly which subclass to create. So for example, if the type is gold, I need to know, okay, yeah, this is the gold subtype. Same for titanium, same for platinum. And then let's say I'm going to create objects in multiple places. Then should I duplicate this logic everywhere? Is it a good design? No, we shouldn't be doing that. There should be some factory which should be responsible for doing all of this stuff, because I don't need, first of all, I don't need to duplicate that everywhere. And secondly, I don't actually need to know about that, because I need to just provide it the card type and it should just create the appropriate type. So the solution is actually very simple. We can just create a class called public class, let's say credit card factory. And in here, actually, I think AI has detected that I'm going to do a factory. Let's see what it can do. Yes, here. Yeah. So credit card factory, and then we have a function called credit card, get credit card. And instead of like I'm just providing it a card type and gold, titanium, and platinum, it is creating a type like appropriate object of that. Now in here, I don't need to know all of this stuff. I just need to say card details is equal to this credit card factory, the credit card factory dot get credit card, and I'm going to provide it a card. Now it will provide me, and it will basically create and provide me a type, like a specific type of credit card. I don't need to know what is that. This function should be clean, like this doesn't know anything about that. So now it can just proceed, continue, like, and do all of the stuff that it was supposed to do, instead of knowing about the implementation details. These are the implementations which we have put in a factory, and everywhere where I need that, I don't need to know about any of the subclass. The caller should never be aware of these things. It should be abstracted inside a factory. This is just one example of a factory pattern, and I think this example is quite basic. That's why we might not think that, yeah, this is an overkill or over engineering. But yeah, if we look at the complex examples, then it will make more sense, but we have limited time, so we can't really go into that much complexity. Um, Now let's look at the best practices. So the best practices, like first we have to start with the preparation. The very first is to have like test in place. We should have the code covered by the unit test, because we are going to change the internal implementation. We might add a lot of bugs while we are doing a refactoring. So we need to have test in place first, and then understand the code thoroughly as well, because when we are making changes, we should know, even if it is suggested by GitHub Copilot, I should know exactly, should I accept this suggestion or should I not accept this suggestion? And I can only make a decision if I understand the code, and then plan the refactoring. So refactoring is not about like just opening a service and like start refactoring the whole application. It is about listing down different classes, files, or modules that we want to refactor and attacking them one by one. Don't like start refactoring the whole application all at once. It should be like, yeah, this set a target for like one class or one file, and that's it. Like it should be very small. When we are going to execution, the execution should be like make small and incremental changes. So as we are releasing them, they are testable. We are already covered by a unit test, but we are also making smaller changes. So there is less chance of like there's less chance of like causing bigger regressions or anything like that. And also we should refactor in isolation, which means like there is no change to external behavior. Refactoring is purely for maintenance, and it is the internal implementation of the software. It shouldn't change any kind of output or any external behavior which was happening before. And as we are doing refactoring, we should measure, like for example, the tracking technical depth, the sonar cube. Like it is, I think it's a quite good tool, which just basically will tell us like, yeah, now you are removing the code duplication. We can see that trend if we are going down or not. Similar with the code smells, like do we the code smells are they going down or not? Like same for the other metrics. So we have to keep looking at the trend to make sure that we are doing the right thing, and not just basically refactoring from one bad state into another bad state. So we should be moving towards improvement and not towards just like rearranging the stuff. Refactoring is never about like rearranging stuff. It is more about like following certain principles to actually make it better and measurably better. Um, Finally, we have this common refactoring mistakes. Yeah. So the first and the most common one is the refactoring without test. We should not with refactor without test any class, any function. I think in all the examples that I showed you, we didn't change anything. Like we didn't change any like the number of parameters the function was taking or anything like that. We're just changing the internal implementation. Sometimes, yes, we are changing the function like name. We are changing the prototype. Oh, sorry, the parameters. We are doing those changes, but that's fine. But if we have test in place, we are confident that those changes are covered by the test. And if we need to update the test, we can definitely update the test as well. But test give us certain level of confidence in our changes. The next is the Big Bang refactoring. Yeah, I was already told like Big Bang refactoring. No, it's not recommended at all. It's never about like Big Bang. It's about like smaller modular refactorings, and measuring as we refactor. So no, Big Bang refactoring is no, no. And then premature optimization. So premature optimization is basically when we start optimizing without knowing that this was the bottleneck or not. Like for example, the example where I showed that converting a synchronous to asynchronous, so it doesn't mean that I should go ahead and start converting every synchronous function into an asynchronous function. It should be like, first I need to verify that yeah, this is the root of the problem. And if I know that what is the runtime of this function, we can use profiler. We have a lot of measurement tools. So once we understand that, yeah, this is the thing which is slowing down my main thread, my UI thread, or my whole application, then only we should go towards optimization, like figuring out which function is taking more CPU, it is taking more like network time, more IO bound operations. Then we can go towards the optimization. So yeah, but we shouldn't do it prematurely and without like it's not about guessing. Otherwise, it can even have like a reverse effect. Like if I start making every function from synchronous to asynchronous, it will start hurting my application performance because here it needs to switch the context. It needs to create a state machine behind the scenes. So there is a lot of work when we are dealing with synchronous, asynchronous functions, which is done by a compiler behind the scene. So we shouldn't prematurely do that. And yeah, I hope that was interesting and knowledgeable. Do we have any questions? I'm not sure how do we take the questions. Do we take the questions in the chat? I see one chat message. I have two questions. Which metrics actually help determine whether refactoring was successful? And how can you balance code flexibility and complexity to avoid over-engineering? Okay, I'll go back to the metric slide, this code quality metrics. So regarding the first questions, which metrics actually help determine whether refactoring was successful? So to me, the most important one, uh, like first of all, is the readability of the code. So once we have refactored the code, not a tiny, like it shouldn't be like a big bang, but a smaller refactoring. Then as we go ahead and start making more changes to the code, we should start noticing that, yeah, the readability is getting better. This is coming from the developer experience and like not from the SonarQube or anything. If we want to measure it automatically, like using SonarQube as well, then here. So we have basically readability issues, like which is basically code smells and this kind of stuff reported by SonarQube. We can understand that, yeah, this is, we have both ways. We have the automatic way, which is like a report generated by the code analysis tool. And secondly, it's again the developer experience as well. Like as a team, as an engineer who is working on the code, we should start feeling more comfortable. Like, for example, we are going to see like, okay, yeah, the number of bugs that we were getting, now they have started going down. The code, for example, with the testability, the coverage of the code has started going up. Previously, the code was bad designed. It wasn't testable at all. It is becoming easier to test now. Like people will start writing more tests. So there is no like one metric we can say that, yeah, this is like, okay, now the code quality has improved, but it is basically the combination of all of these metrics, like the developer efficiency, the code efficiency, maintainability. So all of these metrics will start giving some indication that, yeah, we are going in the right direction, but there is like no single metric that can tell us. And how can we balance code flexibility and complexity to avoid over engineering? Over engineering is definitely a problem. Like, for example, if I have a function, it is doing a very small thing, I start go and implement the, let's say, the factory pattern, the builder pattern. No, that's a no. I think like there is no like right or wrong answer here. It's all about finding a balance. So once we start going towards the patterns, they itself have like a lot of code that is basically required to implement the pattern, like creating new classes, new interfaces, and all that. So that is over engineering. It's up to the engineer, like when do you feel comfortable that this current code that we have, it is not like to me, like for example, in my experience, I mostly look at like how comfortable and how readable that code is, like how comfortable I'm feeling while adding something in the code. And if we start noticing that, yeah, everyone is started complaining about certain class, like for example, we are started like for example, like people are scared to touch a certain part of the code, like certain class. Yeah, oh no, I'm going not going to touch that. So then it means like that class has issues for sure. That function, like which no one wants to touch. As soon as we realize that that certain part of the code has issues, we should start thinking about refactoring that. Don't refactor it early on, like just for the sake of refactoring. It should only be when we are seeing the metrics going in the wrong direction, or when we are starting feeling uncomfortable with the current code, like making a feature is taking forever, developer velocity has gone down, like just adding one property it took like maybe a week or so. So it's all about like finding a balance. I hope that answered the question. In what cases can refactoring slow down the development process, and is it still worth doing? I think that's really a good question. So refactoring definitely can slow down the process, but it has pros and cons both. Like for instance, if I ask someone like an engineer to just add a small thing and they said, okay, I need to redo this whole class, then I don't think in that case refactoring makes sense. So if you are going to change a function and you notice that that function, it has a lot of issues, I mean the set of guidelines that I shared, you can check against that. So that, I think that is a time when we should start thinking about we should start thinking about the refactoring. And then we have to be proactive about the communication, like for example, only start with refactoring when all the stakeholders are aligned. Like for example, if tomorrow is a deadline and today I start refactoring and like redoing the whole stuff using design patterns, no, it's not going to work like that, because at the end of the day, all of the software is basically it's for the business, right? Like and business is more about features. It's not about like how the code looks beautiful. So it's more about like being more, I mean, being communicate properly. Like this is something like, and also discuss with your peer engineers. Like, okay, I'm going to refactor this thing. Does it make sense or not? And also like refactor a small part of that. And definitely it will add some overhead to the development process. But if you have the test, if you know exactly like which part are you going to refactor, and that part is quite small, it shouldn't slow down the process. It will just add like a small overhead into that process. Like if if it was, for example, going to take like 1 week, maybe it will take like 1 or 2 days extra if we are comfortable. But if we are going to do a big refactor and that's going to multiply the time by, let's say, 3x, then in that case, it's going to be a problem. I mean, I don't think it's worth doing in that case. So it should be like a smaller refactoring. And if for example, if you're going to do a bigger refactoring, like for example, refactoring a whole class or something, then it is better to basically factor that time into the development process instead of like, I mean, just committing to something and then getting into the refactoring and never coming out of that refactoring on time. I hope that helps. Do we have more questions? And I will just like to add one more thing. So the Sonar Cube thing I shared here. So this is quite an interesting thing, like keeping an eye on the overall health of the code. It doesn't mean that we have to follow each and everything. Like for example, if Sonar is saying that you have like 10% code duplication, it doesn't mean that I should start digging into the code and trying to find. But for example, if with every day the SonarCube is saying that, yeah, your code duplication trend is going upwards, then it means something is wrong. Like we are basically duplicating the code. If the trend is staying consistent, then we are still okay. Like we are not, I mean, for example, in this current screenshot, it is like 0.3% duplication. Like I wouldn't worry about that duplication at all, even if it was like 10%. But if it was consistently going up, then it means something is wrong and I should take action to stop that and basically start coming towards the improvement. And same for code coverage. Like if the code coverage is going down, it indicates a problem that maybe people are writing more code which is not testable and people are not writing test. So it's all about like then finding metrics and also understanding from the the developer experience. Like we, for example, discussing in the retrospectives, like what what people are facing, what kind of issues people are facing, and is there anything that can be done, like a refactoring or anything like that. So it's a combination of these metrics versus the developer experience, both that can help us decide like which part to refactor and exactly when to refactor. Do we have more questions?
I guess that we have no questions. Thank you so much for the lecture. It was so interesting. And probably tomorrow I can send you some comments about it, like review and so on, from our guests. So thank you so much. Have a great day.
Thank you,
Thank
everyone.
you,
Bye.
everyone. Bye.